Good afternoon, and thank you again to join also today this Business Skill Lab under the framework of Nishati project. And so it's really a pleasure for me to have again as teacher and as Professor Flavio Andreoli, that is CEO of Epico and Hydrowatt company, which work in the field of macro hydro system. And the lesson, the 2 hours of today, will be focused on the main criteria no, for the design, the development, installation of energy plants in hydro, and also the main criticalities. So the idea is to share with you a concrete experience how to work in the field of energy. And for that, we have one of the experts because directly involved in the installation, in the design, and all the process for the authorization of a plant. So as yesterday, let me give you just few information. As first, it's a pleasure for us if you want to make some questions, no? So please use the chat. At the end of the first 45 minutes, Flavio will give you the floor, so you can unmute your microphone. My invitation is that until this time, please mute your microphone, giving Flavio the opportunity to speak without problem. And then Flavio will give you the floor, so you can unmute your microphone, or you can type directly your question on the chat, and I will read your question for you. Second point, remember, all of you will receive the teaching note at the end of these 5 days training session, so don't worry. But under the condition that I will ask you to fill an evaluation form that is a survey concerning about your feedback, about your opinion about the project, the training session. So please, at the end of the last day, we will give you 10 minutes to 15 minutes, no more, for filling the form. And so you will receive both the teaching note and the certificate of participation if you need. So don't ask again, Flavio, the teaching note, because I'm responsible for that. I will provide all the teaching notes at the end of the training session, together with the videos, if you have the pleasure to watch again this lesson. The training session will last around 2 hours, so we will close at 4 in Italy and 5 or 4 in your countries. Welcome again, and I think, Flavio, we can start your training session. So don't worry, I will admit the new students if required, and you can go ahead with your training. So thank you very much and join the lesson.
Thank you, Katusha. Hello to everybody. Thank you for attending to this training session. Actually, I'm not a professor. I am a professional. I'm an hydraulic engineer. So I went through my classical studies in Italy. And after that, I graduated in civil hydraulic engineer. And I also have a PhD in energetical engineer. But since the very beginning of my career, I have made the entrepreneur. I mean, I can define myself as entrepreneur. The idea was at the end of the 90s to invest in new sources, new form of energies. At the time in Italy, the thermal energy was the main source of energy, but originally, hello? Yeah, but originally the industrial system in Italy was sourced by hydraulic energy. Then, of course, after the Second World War in the 50s, 60s, and 70s, a lot of thermal storage was built. So it was a kind of a centralized way of producing energy with a huge power plant. But at the end of the century, at the end, let's say half of the 90s, a new wave of thinking came across Europe in order to habilitate a new form of energy. So I started at that very moment, and since then we have we have we have developed a lot of hydropower. The core of my business is hydropower, even though we invest as a company in photovoltaic and solid biomasses. Now I am going to share the my presentation. Okay, can you see it?
Not yet.
Not
Yes.
yet.
Now you see it?
Not
Not
yet.
Not yet. Fantastic.
No, don't worry. Try again.
So, schermo. Condividi.
Okay. Yes, Flavio.
Okay.
Now it works. So you can start the presentation on the right. Yeah, sure.
Okay.
So we can see the presentation in the perfect way.
Okay. So let's go on. Oh, okay. This is the index. This is me. Okay. With my CV, which is exactly what I mentioned before. This is the structure of my company. We are two firms, two partners. It's me and my brother, who both of us established the company at the end of the 90s. And you see that there are companies working, NPV, so just SPV, special purpose vehicles, which are made, each of them invested in some power plants. We also have Epico Georgia, which is the owner of a power plant in Caucasian Georgia. Okay, we invest in biomass, hydroelectric, and solar, but mainly we are hydroelectric people. This is a brief history, as I mentioned, started in 1999, and we went through the years investing and developing new power plants. Now, let's get into the point. I came here to Africa a couple of times for Nishati project. And so I had the opportunity to watch around and to see your beautiful countries, Rwanda, Tanzania, and Uganda, and thinking about the local development. So I would like to focus some strategic concept, which I think are the base of any kind of entrepreneurship you wanna tackle. Let's ask ourselves what an infrastructure is. Okay, let's go and read it. Because when we are talking about development of a country, the development means doing something, creating something, building up something, creating infrastructure. So let's see what the definition of infrastructure is, because this is a key point that I hope you can understand. I will read it, so it's simpler. The term infrastructures is used to designate that complex of capital goods. Okay? Underline this word, capital goods, that provide a series of services that are indispensable for the functioning of the economic system: roads, railways, ports, school, hospital, dams, drainage, power station, and so on. So, what is an infrastructure? Is a capital goods. Okay, let's go ahead. All infrastructure have common characteristics. They are capital intensive and are permanent work for decades. Building an infrastructure, whatever it may be, requires a huge investment concentrated in the initial phase of construction of the work, which can be repaid during the useful life of the work through the cash flow it generates. Okay, this is the key point of any development. Either you are thinking about a huge power plant or a small local power plant for maybe for some local purposes. Okay, but you are always talking about an infrastructure. Again, in an infrastructure is a capital goods, money. If you are thinking to development, you need money because you need money to create the infrastructure, which is another immanent, permanent characteristic of the infrastructure. The infrastructure, imagine a port. I'm going to show you some pictures. Imagine a port, an airport, an hospital. They need to be constructed. The first phase of the life of an infrastructure is to build it up, a bridge. Okay, imagine to your local community, an infrastructure could be a bridge on a local river, could be a power station, could be a small airport, could be a small hospital. The first thing you need to do is to create it, to build it, and you need to have the money for making this. Then, how do you repay? How do you pay back the initial investment? You will pay back the initial investment by using the infrastructure during its useful life. Let's go ahead. Let's see if it can be clear. Now it doesn't move. Okay. Okay, so you can see here a typical example of infrastructure. You see, this is a huge thermal power plant, which has a useful life of about 30-35 years. Turbogas thermal power plant, which has a useful life of 15 to 20 years. A large hydro, more than 50 years of useful life. A small hydro, 30 to 50. Photovoltaic system, and so on, and wind power plant. Those are energetical infrastructures, okay? But you see, imagine that development of communities and development of countries are based on those power plants. But first, you need to create them, to build them. Okay, so take, for example, this huge hydro. Imagine that you have to build it, to manufacture it. So imagine that you have to invest a huge quantity of money at the beginning of the useful life of this infrastructure. I can understand why the button doesn't work. Okay. So this is, you see, this is an irrigation dam, a typical infrastructure. The local agricultural system is based on the water coming from this dam. This is an earth dam south of Italy. You see that the crown of the dam is about 1 kilometer long. This is huge. Is huge. They took about 10 years to build, to create the dam, but the works were carried on from 1970 to 1980, so 10 years. But now all this area of Italy is irrigated by this dam. So the dam is the base of a local development, talking about agriculture. If I go on, non so perché, you see some pictures. You see, this is the dam. Now I'm showing you a particular of this area. This is the intake area, okay, where the water, the intake of the irrigation system, where the water flows from the artificial lake into the irrigation system. I can understand, Katyusha, why if I push the button, it doesn't go on. So I need to scroll with the mouse. Okay. So,
Because probably you have two options to go ahead, so use the one which works.
okay. So this is the particular of the intake of the dam. You see the age of one man compared to the overall structure. Okay, and again, those are the gates, the superficial gates of the dam, and you see how small are those men. The reservoir is 40 million cubic meter. Okay, why I'm showing you this? I'm showing you this for giving you the exact idea of what an infrastructure is. I can show you, maybe I have other pictures, but let's go on. Um, so the first thing you need are money. Otherwise, you are naive. I a lot of time in my life traveling across Italy, but also in other part of the world. A lot of people ask me, why don't we? I have some ideas. There is a big river, there is a big lake. Why don't you come here and you invest your money? Why don't you create a new power plant and so on? And I said to everybody, the first things that you need to have are money. So for Africa, especially, if you want to create development, local development, you need to know how to ask for the money. You need to very well understand the concept that you need money for creating infrastructure. And if you need the money, you need to ask for the money. This is a job. This is a work. It's not easy. You have a lot of natural resources, a lot of them, a lot of natural resources. Both you have water, you have sun, you have minerals, you have materials, raw materials, you have wastes from agriculture. So you have a lot of resources. But what do you need to create and to transform your resources in development? Money. Okay. So this is a very important concept, because otherwise you think you could develop your country, but effectively you do not do it. Okay. For really creative development, you need to, uh, I mean, begin an economical cycle. Okay. So first of all, you need to ask for the money. Whatever the project you have in your mind, could it be a biomass project? Could it be PV, photovoltaic, hydro, anything you have in your mind? You need to find out the money. So which kind of money you need? As I mentioned before, an infrastructure has whatever infrastructure it is, has a very long life. So you need a first investment, the first stage of the investment at the very beginning, which pay it back in during the useful life of the during his useful life. So what you have to search for, you have to search for financial operators that operate on a long-term basis, because what you have to ask for to the financial operators, you have to go to the guys and say, hey guys, I have an idea. In my community, we have a lot of wastes from agriculture. I can create a biomass plant. Okay, that's a wonderful idea. And I need to invest 1 million US dollar for creating, building up, buying the machines, and then I can pay back my investment selling the power to the local community, or selling the thermal power for about 20 or 15 years. Okay, so what are you searching for if you need the money? You are searching for some financial operators which has a long-term basis, not a short-term basis. you are not making you are making development. You are not making speculation. So this is another concept. You have to think that is on one hand the speculation, on the other hand is the development. One is the opposite of the other. We are talking about development. My job is to develop project, not to speculate with the finance. Okay. So let's go to long-term basis financial operators. Of course, once you go to long-term financial operators, you need to know their language. You need to know the basic rules for asking the money. Okay. Why? Because they are especially large national banks or international banks like the World Bank, Asian Development Bank, African Development Bank, and others. Okay. So you need to know that you have to deal with that people, which is not easy. Okay. What do you need to tell them? Who are you, first of all? Okay. So you are you have the idea of a project, then you have to demonstrate that you are credit worth. Okay. That you are able to pay back your loan. Then, of course, you have uh, to give them a power generation evaluation. We are talking about, of course, energetical infrastructure, the cash flow analysis, the financial guarantees. Okay, they are lending you some money. How can you guarantee your the loan? So probably they are going to ask you the infrastructure itself of the cash flow deriving from the infrastructures, the financial cost, the financing costs. You have to understand and to evaluate which is the cost of the money. You go to the banks because the banks are selling money, because you need money for the development, and they are selling a good. Which name is money? Money is good. Think about money like fruit. Okay, it's a product which is sold on the market and has a price. The price of the money is the interest rate, and we will see later how the interest rate can interact with the value of the investment. Then there is you have to demonstrate that you are practically able to construct the power plant or the infrastructure. Let's call it infrastructures for the moment. Why? Because the construction phase is the most dangerous phase of the life, because during the construction phase you are spending the money, but you are not selling anything. You are not selling any kind of service. You are not selling energy. You are not selling services like airport or hospital and so on. You are in the middle of the construction and everything can happen. So this is very important to demonstrate to the financial system that your construction phase is safe. Then once your infrastructure is ready, that you have to demonstrate that you are capable of managing it. What do you do with an infrastructure without a proper management system? So that you have to demonstrate that you are capable of managing it or to operate it. And then the plant must be insured against everything. Fire, for example. The insurances are both during the phase of construction, like CIF, constructional risk, and erectional risk, which are the typically insurances policies used during the construction phase. And then the operational phase, an all risk policy covering the damage of and production loss. So from those few words, I wanted to give you ideas how much the development of a country is difficult. It's not just having ideas. Having ideas is important. But as I mentioned, Africa is full of ideas. Full. you have everything as talking about natural resources, but then you have to translate the resources in infrastructure. Let's go on. Those are some kind of example of international long-term basis institution which are specially focused on the development. So you see Uganda Development Bank, East African Development, African Development Bank, okay, and insurances company. Okay, so I wrote down some insurances company names for you, bank in Tanzania, and so on, just to give you some ideas. If you go to if you browse their website, you will find some application form and so on. And if you get deep inside it, you will see how difficult is to deal with a financial institution. Okay, so because creating infrastructure is such a difficult thing. You see, first of all, as I told you, you need the concept at the base of infrastructure is capital good, so money. Second, let's focus on energetical infrastructure, especially on hydropower. Okay, what do you need to develop a power plant, an hydro power plant? Okay, no, we have. Okay. First of all, you need to be authorized because again, once you have the idea it's important, but in order to translate the idea in actual structure, you need to ask for the permission. If we are talking about hydropower, you need to have the hydropower authorization. You have to ask for the use of the water. The water is of the community. Okay, everywhere in the world the concept slightly changes, but basically the basic concept is the water is a common is of common use. It's not private. So you have to ask to the state because generally the water is owned by the state in order to save the equal use of this resource. So you have to ask for the permission of the water, and but for asking the permission, you need to know how much water you need to ask for, and for this reason, you need to have a data collection. You have to study your territory and to understand very well how many water you have disposable at disposition in your territory. Okay. In this case, the Nishati project is aimed to focus on small hydropower project, which can really simplify the studies and, of course, simplify also the financial activities because you require a less amount of money compared to the huge power plant. Then you have to demonstrate that your infrastructure is not harmful for the community or for the landscape. Because imagine you can use a river for a big power plant, and with that power, you can supply maybe million of people. But if on the other hand, you dry up the river, you are creating a serious damage, a serious harm to the environment. So every infrastructure must be useful to the local community, but must not be harmful to the environment system or to the social life. This is a very important concept. Okay, we have lacked of understanding of this concept during the 70s, the 80s, and the 90s, and sometimes in Africa, in Europe, in Asia, everywhere. So we have founded a huge infrastructure, creating more troubles than useful things, that advantages. So if you create an infrastructure, this infrastructure must be not dangerous for the environment and for the sociality. Okay. So you need the impact study, for example, the environmental impact study, which must be what happened here? What is it?
So please, so I can check the list of participants. Be serious. It's not a way to joke with the presentation. And so I invite the person who's writing on the presentation to stop. And Flavio, you have to close the presentation and to start again.
I have to close the presentation.
Yeah, because so it's the only way to delete.
Che non mi funzionano i cosi, io non riesco a capire come si fa.
No, no, don't. Click on ask.
Non mi funziona. Ah, ok.
Okay, give the time. And then I try to start again the presentation.
Okay, so now what I have to
Sotto,
do. And what? Pardon?
down,
Down.
on the right.
No, I don't.
On the right.
I don't have it.
Yes, Flavio, is a PowerPoint presentation and the button on the right.
Yes.
Near Zoom. Near Zoom.
Yeah, this is. I'm here.
Ok, no. Sorry, I will speak in Italian. Apri la presentazione dove c'è la barretta dello zoom a destra, in basso a destra.
Sì.
In basso a destra i quattro quadratini. Non la barra di PowerPoint, Flavio. Vai. Allora, alza un pochetto il cursore. Vai tutto
Ah,
a destra, tutto a destra, tutto a destra, tutto a destra, tutto a destra, vai giù. Eccolo là, là lo fai partire.
questo è.
A sinistra della barra, a sinistra di questa barra. Ancora a sinistra.
Non c'ho niente, non c'ho.
Ce l'hai, lo vedo io, Flavio. Segui me. Sopra la nuvoletta. Ok, adesso l'hai spostato. Ok, vai. Allora, perfetto, là sopra. Perfetto, vai. Vediamo se si vede ancora.
Yeah,
Mm.
this is still.
Can you delete the lines, please? Joseph, can you delete the lines? Okay, try to go ahead and then we will
Vabbè.
have a break. We'll try to solve the
Yeah,
problem.
I will go. I'm going.
Usually if you, no, sorry, stop the sharing, Flavio, and share again the presentation. Yeah, thank you. Yes, please. Okay, start again the presentation. Okay, so
Okay.
yes.
Okay. So,
And sorry. Really, I invite the people to be serious for 1 hour, no more, because so there are a lot of effort in the organization of this kind of trainings for you. So please, I invite the person. Okay, welcome, Joseph. If you can, so it's your name, but please stop joking and let's go ahead.
yeah, I understand that this concept can be, I mean, can seems not so exciting, but they are the base of any
No,
kind of
Flavio. It's not the
ah,
topic. Be sure. Be
okay.
sure. Go ahead.
Anyway, so let's go ahead. So what is important in thinking about development? So you have to ask for the authorization if you're dealing with hydro, you have to ask for the permission of the abstraction of the water, which means to have a data collection and to create a model in order to minimize the burden of those data collection. So you go on small power plants. Then you have to have a general authorization, which is in common with all the infrastructure. The authorization basically to construct the structure. Um, those phases are extremely difficult and long, and they could cost from the 3 to 5% of the total project to the total cost of the project, and they could last for years. Okay, they could last for years because, as I mentioned before, the infrastructure has an interaction with the social local community and with the environment and landscape. So it's a difficult things to make a good job. to be absolutely sure that what you are thinking about for local development is really useful. So, being so difficult to get the money for it, because you have to ask a lot of money, being quite long and expensive to ask for the permission, and aiming nichati the scope of the local of enhanced local development, we have to find out a feasible model, which is based basically on the dimension, okay, or on two things. We need to find an easy model so that we can spend less, and in this case, the dimension of the power of the infrastructure must be low. The dimension of the power plant must be a small power plant. When I talk about a small power plant, I'm thinking about something between 100 kilowatt up to 10 megawatt. Okay, so this means that you need to use local rivers or local hydraulic infrastructures. And so we are getting into the field of the decentralized or dispersed generation. Those are, I don't know whether from where, which kind of studies you are coming from. By the way, it's 3:45, so I would like to interact with you. Otherwise, I have not the feeling whether I am talking to myself or I am interacting with somebody. Please interact with me and tell me, for example, which kind of studies you are coming from, either scientific or humanistic studies. Because I'm now trying to give you some concept which are basically belonging to engineering. Basically, I am an engineer, of course, so I'm giving you some topics, some arguments related more on engineering. Of course, I'm not getting so deep in that, but what I think they are basic concept that you have to know. So please, if anybody wants to interact with me, I would be glad. So you give me also 5 minutes of rest. Anyone?
They are writing on the chat, Flavio. If you go back down
Ah,
chat, you can see
ah,
some of them are engineers like us,
great.
and then other from humanities and computational science, I suppose, statistics and data science. So we have civil engineering. So we have many
Okay.
backgrounds.
Okay. Okay.
You
Okay.
must be you must be able to be understandable by all of them.
See, yes. So what I have in my mind, I think that the I mean the world now is going through or versus in a direction of decentralized development. We are coming from a period of huge infrastructures, especially energetical infrastructures. As I mentioned before, we are coming from a period of very big power plants like this one. Okay, those one are power plants of capability, of capacity of thousands of megawatts. So the idea was to install huge power plant in order to serve big part of territory. With the advent of the renewable energies, this paradigm is changed, and we are going now towards a direction of decentralized um, development, especially in energetical infrastructure, but not only in energetical infrastructure, also, for example, the health system. I mean, we are thinking about a serious change between a huge hospital, centralized hospital, and different distributed hospital in a region, in a peripheral region. So, I mean, we are thinking again the concept of development. So here, basically, is represented with two drawings, the idea of a centralized generation and distribution generation. With the upcoming of the renewable energies, of course, being the renewable energies not programmable and generally not big power plant, of course, the system is going through a decentralized distribution. Okay, and so we are. Let's here it is. So this is the scheme of a local development. In this case, we are using a photovoltaic. Then you see that the number three is a battery load regulator. Then there are loads, seven, okay, and the storage system. The four is storage system. So this is a kind of energetical system which is developing now, is underdeveloped in Europe. Actually, is already developed, and that I suggest to use in Africa, because you have a lot of sun, and in this case you don't need to be connected to the lines, to the national grid. Okay, if this is the structure of a mini grid, but if to a mini grid you add the capability, the possibility to automate itself, it will become a smart grid. So if you add to a grid the storage system, the load regulator, and the converter, and a computer, and the full automation that can storage the load and then give back the load during the night, for example, charging during the day, this grid becomes a smart grid. The technologies used by at this moment for creating smart grids are called grid formers, basically. Okay, so this is the idea, the different the grid forming technologies. Those are the ideas between the difference between, you see the scheme here. There's a big power station, high voltage line, medium voltage line, and a low voltage to the residential consumers. Okay, so this is the classical schemes. What is the problem? I mean, now I'm getting to some very technical, probably concept, but I mean, I try to explain you here. Okay, those are the in details what I'm talking about. Here in this area, there is the extra high voltage system, so the huge power plant and the huge consumers. Then in the middle, there is the high voltage consumers and producers. Then from transmission, when we talk about when we speak about transmission, we intend all those lines crossing the countries, carrying and transmitting a huge load of power. Then locally, the transmission become distributions. Once you have reached with a high voltage line the local community, you distribute the energy into the local communities. Okay, so you have at the distribution level, you have the loads, the consumers, but you have also the producers. So look at down here, solar farms and wind farms. Okay, this is how a modern system works now. What we want to do, we want to go through this system, because if you see in the lower part of the chart in distribution grid, you will find both consumers and producers. So you can couple consumers to producers, and the energy stays into this distribution grid without getting up to the transmission grid. This is, I mean, a key concept, especially in Europe, where in order to absorb the huge quantity of renewable energy, we have to reinforce the transmission lines, investing billions of euros for that. Imagine that the Terna, which is the transmission company of Italy, is has an industrial business plan for the next 10 years, which consists of 20 billion euros of investment only to reinforce the transmission lines. Okay, again, what I'm thinking, what I see when I'm think to African countries, I see actually this model here. Okay, I see this. I don't see now huge power plants. I think this is not modern anymore. Even talking about nuclear, there is the idea of creating small nuclear plants, not huge nuclear plants. So now we are going into the direction, through the direction of creating a local development. Let's go ahead. Now we want to search for. After this, I give you some pictures and some videos in order to facilitate the understanding of what I'm talking about. We are going to search for a model. Why? Because we have seen that infrastructure needs money and permission. So we want to create something which is cheap and easy to develop. So let's create a model. Let's create an easy model or an easier model, something which could really be feasible. Okay, what we have, how do I started? My experience was at that time in the 90s, I didn't have much money to invest, but I wanted to invest in renewable energy, small hydro. So I figured out a model which consisted in the using existing hydraulic infrastructures. I'm talking about aqueducts or irrigation system. Imagine that when you create an hydraulic infrastructure for irrigation, for example, you have to create canals and I mean generally it's a kind of development created in decades because first you start to irrigate a part of the territory, secondly a new part, and so on. You go on for decades. Inside those network of canals and irrigation system, you can find out some hydraulic energy which is not used but must be dispersed because the excess of hydraulic energy is dangerous for the irrigation. The water coming from the irrigation system must have a steady flow and a certain kind of speed of the water. It must not exceed a certain amount because otherwise it's not irrigated but we erode and it will eat out the fields. Okay, so sometimes there is an excess of dangerous energy. That energy is useful for hydropower. That was my idea. Actually, I applied this concept in an aqueduct, where in Italy we have in the area where I started, there are big mountains ranging from 900 meters to the sea level. So the sources of the aqueduct was higher than 900 meters, but the distribution of the water was down at the sea level. So the water has to waste to lose 900 meters, and that one is all useful power for hydropower. So I basically used the water turbine as energy dissipators and simultaneously producing energy. This was my idea. I mean, it's not my idea actually. It's something which has been done since the Egyptian and Mesopotamian and so on. It's an old idea, the co-use of the water. So I am co-using the water and the infrastructures. Okay, the infrastructure and the water are used both for irrigation or for fresh water and for energy. This was my idea. Why I had to go deep in this concept because I didn't have money. And of course, if you use something which is already existing, you don't have to invest in that. So imagine that I am using the canal for the irrigation system. I don't have to build a new canal, for example. So this give you the ideas. And of course, everything is easier because the water is already there, is already abducted, and of course, all the authorization process is much easier. Okay, so this is the model I have been used since my very beginning, the co-use of water and infrastructure. And we applied those concepts to all the hydraulic infrastructure on the territory, the dam release, the weir of river regulation, the biomass co-use. The same thing is in biomass. Imagine, I mentioned before, you have, when I visited your countries, I have visited a lot of local markets. A lot, I love the markets. So I went into tens of local markets. And what I've noticed is that you have an enormous, a huge quantity of wastes, of agricultural wastes, fruit, rotten fruit, for example. That one is energy, energy. So that one you have to see that not as a waste, but energy. So you can use agriculture both for feeding the people and for creating and producing energy. We do it with our biomass power plant. We are using wood chips coming from the waste of the forestry industry. Okay. In Italy, in Europe, we have a kind of forests that need to be periodically cut down for maintenance. Okay, so the biggest part of the trunk of the timber goes to the industry. But then there are wastes, smaller pieces of wood. We are buying those woods and we use and we co-use that wood for creating thermal energy, and from thermal energy we create electrical energy. I have no, questo manco questo non funziona. Okay. So now this is just give you some brief idea. This is a power plant on aqueduct. As you see, look at here. This is the line. Okay, where the cursor is. This is the line of the aqueduct. The aqueduct is just carrying water for feeding the people. And this is the bypass where I have installed my turbine. This one is the dissipation valve. Why? Because, as I mentioned before, in this case, there is a pressure too high for the system in order to be operated. So the pressure, the water pressure must be reduced. The reducing system is the dissipation valve, which is F and G basically. So in G, the water dissipates the excess of energy. But then we said, why are we dissipating this energy? Let's transform the energy in hydropower. And so we bypassed the valve G, you see here. We bypassed the valve. With this bypass, the turbine, and then again the water flows back into the aqueduct. Okay, so this is a typical application. The aqueduct was existing, the valve was existing, so I only needed to create this bypass here. And of course, as you can imagine, this system is much cheaper than to build, to create from scratch a power plant of the same power. Okay, those are the pictures. You see, it's quite compact, small, and requires a kind of technology. Then, this is a power plant of an irrigation canal, as I mentioned. Okay, look at, I will show you a video. The water is coming from down from a hillside, okay, up the mountains here. It flows from left to right, and the water, you see the loss of quota of the canal of the channel. This is a step at the channel that must be that is used in order to let the water lose the head. Otherwise, the speed of the water going flowing into the field would be too much. So originally, the irrigation system built created this stepped canal, and we bypassed the stepped canals using a penstock. I mean, basically a steel pipe going into this white building and creating energy. Okay. This is seen. This is not sure, let me say it here. This is seen from down the valley. Okay, this is uphill and then this is downhill. Okay, so you see this is a huge dam, and this is the vital flow. So each dam, the purpose of the dam is stopping a river and create an artificial basin, but you cannot kill the river. You cannot stop 100% the river, otherwise you will kill all the natural life after the dam. So you must release a certain amount of water, calling the vital water flowing from the river into the toe of the dam. This one is energy. So you're seeing flowing here. This is the status before our investment. The water is flowing from the dam into the river, and this is the status quo, how it is now. So we have a turbine inside this room, this chamber, which turbines the water coming from the dam. Okay, again, this is another application that we made. And now I'm going to show you a weir on the river. You see, this weir is used in this is a kind of nervous river in the eastern part of Italy. We have big floods here. So the river has been, controlled by a system of weirs. This is a big weir. It's about basically 100 meters weir with a head of about 10 meters. Okay. So we have used these weirs in order to collect the water inside our power plants. Here, you see here, this is the power plants. Okay, this is the weirs seen from high to low, from mountain to valley. And if I go ahead, okay, yeah, this is the same. You see, this is the weir and this is the power plant. Okay, so when there is excess of water, we use the weir in order to let the water get inside the power plant, where there is a turbine here, and it flows down again on the bed of the river. This is the biomass plant. So you see there are the forest, in order to give you the idea. Those are in a central Italy forest, and they must be periodically cut in order to keep that maintained. And so we buy out, we purchase the wastes of the woods deriving from the periodically cutting of those woods, of those forests. And those are cheap woods. You see, this is the fuel of our power plant. So we are using basically the maintenance cycle of the forest in order to create renewable energy. Okay. Of course, this is not, I do not recommend it in Africa. I would think more to biomass power plant created by wastes of the agricultural system.
Flavio,
Sì,
if you want to have a short break,
yeah,
there is a question. And
yes.
also invite the others so we can use a five
Okay,
minutes.
let's open the chat.
Yes, for question if you have. And there is just one at the moment, but if you want, you can also mute your microphone. The question is if uh, there is a means specifically at Nishati project to offer technical support in the development of an energy idea to help match with international standards. I don't
No,
know if you want to answer or I can answer for you.
is there a means, is there, John, is there a means specifically at Nishati to offer technical support in the development of an energy to help match with international standard? And this is what we are talking about, actually. But please, Katyusha, you are the.
Yeah, I don't know, John, what do you know about Nishati? Or Nishati is not a company. Nishati is not an officer. We don't provide services, no, as an energy consultant. Nishati is an European project. So what means that a consortium of universities, no, we have two universities from Europe and six universities from
But I was
Yes, please, John. You can unmute your microphone. You can make the question directly. John, please. Okay, in any case, being an European project, so we have many activities to carry out. The project is a capacity building project. It means that our main goal is to create
trying to me.
Yes, now I can hear you. No, now. Um,
Sorry, it seems I'm not got well. I don't know, but I have a network problem. I'm breaking.
I cannot understand you, John. Let me finish. So our idea is to support the students of these six university. You are part of them, no? Creating capability and skills on the three topics of agriculture, renewable technologies, and water management. So you can have the opportunity, no, to receive feedback, qualified feedback from the people from the consortium. So if you have some energy idea you can email your idea to Flavio or to the other professor members of the consortium, and we can give you some feedback concerning your idea. But we are not services for international standard. The verification of international standard. I don't know if this is your questions. And Innocent writes, actually, I also have an idea, but I don't have the funds. I don't have the money. It's a solar powered 100%. It's about reducing post-harvest losses of a fruit farmer.
Innocent, this is exactly what I was mentioning at the beginning of this lab. I know you have ideas. I know you have ideas, of course, but in Uganda, yeah, I agree with you. I agree with you. You have a lot of possibilities, but you don't have the money. So, what is my scope here? My scope here is not to teaching technicalities on how to install a biomass plant or other kind of plant. My experience is to push you to understand very well that you need to deal with the financial system, that if you want to create development for the farmers, for the people, for the communities, you have to deal with the financial system and to understand very well what is the concept of the infrastructures. That again requires an initial investment, and has a long life. So that's the key point. I know that you have ideas, and I'm sure that your ideas is wonderful because it seems very smart using solar power in order to reduce the losses of the harvest. That's great, but again, uh, uh, okay, I get. Thank you for getting my point. This is why I'm talking about giving you these examples, not because I want to show you how good I am, but because I want to show you that you have to struggle with searching for the money. And for searching for the money requires asking for the money. If you want to ask for the money, you have to know what to ask and how to ask. Okay, so you have to have a very clear picture in your mind. Otherwise, any development is impossible. Everything remain on as a scratch, as an idea.
Yes, I want also to underline that nobody will give you the money for nothing. So you have to work searching for money, but also you have to work hard on your idea. So you cannot sell an idea. You must sell an opportunity for the people who will give you the money. So design very well your idea. Prove that it's suitable for the needs, local needs, so that it's sustainable. Create a prototype, give evidence of the cost, but also the incomes. So you have to create, I suppose, I'm not expert on that, but starting from the idea, you have to convince the people that it's a good idea because it can create some incomes and can solve some problems. I'm not a businesswoman, but it's the same approach I use when I design a proposal for a project. When you submit a proposal for the European Commission asking for the money, you must demonstrate to the European Commission that your idea is a good idea because it solves the local problem, because it's relevant, because it's well designed and sustainable, and it can create opportunity at the end. So you must work also on these points, and then if this idea convince you, your friends and your colleagues, you can ask for money because you have opportunity to convince the people who the money has.
Exactly. I will show you. I will show you. Maybe not today. Next time. I mean, a real case business plan. Okay. Now, what I'm going to do is giving you some very general ideas, and then to focus on a real business plan. So I have posted in those labs a real case business plan in order to give you a real idea of what's going on. Now, let's talking about numbers, by the way, because we have mentioned cost. Io non riesco a far funzionare sto cazzo di okay, some costs. You see, I've given you some. Oh, first of all, before I go ahead, you will find after that you have completed your form, you will find two documents from my side. Those slides and a master document, which is not in the form of slides, but is written by myself with my hands. And I suggest to work on the master document because it's much more defined, and I had more opportunities to sharpen some ideas, to get deeper, and to give you more broad ideas of what I'm talking about. Now, let's get into this number 5, parametric values and costs. So how much an infrastructure costs? And let's see some figures. Financing authorization, as we mentioned, is complex and time consuming. The cost of financing authorization accounts for 3 to 5% of the total plan cost, ranging between 6 to 36 months. But I can tell you that it can goes much beyond. It could last 4 or 5 years. Okay, then you have to buy or to spend to invest in design and construction management. Okay, so includes design, safety, and site management, making up. This is about 7 to 10% of the cost of the total investment. Importante. Innocent. You were the guys of the PV, right? Innocent. Dove cavolo sta? Chat. Is it innocent? Innocent. So take a look very well at those numbers, because if you want to create a system for drying, for example, drying up harvest product or so on, you need to create a project. You have to have a project, a technical project. Okay. So you see that if you have to pay for the project it's going to cost you from 7 to 10% plus 3 to 5% for the authorization and financing. The total amount of the intangibles are 10 to 12% of the cost of the value of the construction. And you spend that money before you start the works. Okay? So 90% of those 10-12% is spent before the works. Okay, so you see how you have to plan very well your activities. Then what is the real construction cost? It depends on the technologies, on the sources. Hydropower ranges from 150 to 450 per megawatts for plants under 10 megawatt. For bigger plants, they tend to cost less. But let's use those figures. Wind power, 1,500 to 2,500 per megawatts. Okay, PV, photovoltaic, it ranges from 700 up to 1,200 per megawatt, depending on the cost and on the value of the land. And then the cost of PV, they are, I mean, very much unstable on the international markets due to geopolitical situations. Steam and turbo gas, they cost from 1,000 to 1,200 per megawatt, and turbo gas cost from 800 to 900 per megawatt, respectively. Okay, so you see from these figures, you could say that steam and turbo gas are competitive with respect of photovoltaic and wind power, or let's say. Okay, this is not true, because you have to think that steam and turbo gas, they are programmable, so they can produce energy on the clock. Okay, so 24 hours per day for 12 months per year. PV, wind power, hydropower are not programmable, and they are depending on the quantity of the natural resource. Of course, photovoltaic cannot produce energy during the night. So the number of hours of the photovoltaic ranges between 1,000 and 300 in north of Italy, up to 2,000 hours in Africa, basically. Not more than that, because when the weather, the atmosphere is too hot, the efficiency decreases. Okay, then we are once we think to our infrastructure, we must estimate the cost, but we must also estimate the revenues. And when we deal with energy, what links the revenues to the energy? The production estimation, so the number of kilowatt hours produced, and the value of the kilowatt hours sold. Okay, as I mentioned before, the total number of hours in 1 year is 8,860 hours. But of course, you cannot imagine that you have a non-programmable renewable energy plant. This will work for 8,860 hours per year. Okay, so we are talking about equivalent hours. So the number of hours the plant works at its maximum rate, okay, its maximum installed power. So the hydroelectric production generally ranges from 2050 to 6,000 hours per year. The PV, depending on the latitude and the temperature and terrain, ranges from 1,000 to 100, 1,080, maybe 2,000 hours in south of Italy, and so 2,000 hours, I would say, north of Africa. But even if you go south to the equatorial area, because of the earth temperature, the efficiency decreases. So I would say that the maximum hours a PV plant can work is 2,000. And the wind is from 1,800 to 3,500 for offshore plants. Okay, so if you innocent, you are now innocent is my friend. Again, innocent. If you are thinking about a PV system, for photovoltaic system for agriculture, you have to think that you cannot rely on the nights and on the rainy days, of course, rainy and cloudy days. Okay, so you have to think very well about that. And how do you think very well about that? You need to make a project. And once you need to make a project, this means that you have to pay somebody making the project for you. So you start investing or spending. So this is why, again, you have to think it very well, understand what are the costs of everything. Once you have your ideas, you have written down your business plan, you go with your business plan to ask for the money. And I will show you later a business plan. So the other parameters which involves the estimates are the rev and are the is the electricity value. So what is the value of power in your market? And it depends. It is dependent by tens of factors. Okay, if, for example, in Italy, the energy cost, the energy value of the market is very, very high. It's about these days, this period is about 130, 140 euros per megawatt hour. And this, I think, is the highest price across Europe. Probably in Africa is cheaper, but I you have a lot of blackouts. So it's cheaper, but it's not, the energy is not effective because it's not efficient. It doesn't is not distributed to the consumers because of blackouts, because you have a lack of power, installed power. Okay. But again, if you have to think to your investment, innocent, let's take the idea of innocent. But please, if you have any ideas, write down the ideas, because it helps me to give you practical example. So innocent said, I have an idea. I imagine innocent, the place where normal sunny days and very low rain, less than 30 per year, high temperature through the years, the PV can work better, of course. Okay, so you see, Innocent is still working, is on his project, and he is saying, yes, we must install our power plant where we have dry seasons, very long dry season, sunny days and rain days are less than 30 per year. So probably the equivalent number of hours of the PV plants that Innocent has in his mind is about 1,800 to 2,000 per year, which is very good. But again, once you have your project in your technical project, you also have to couple your technical project with the economical project, because you have to understand how much it costs and how much you will and how much are the revenues are. So you are thinking to sell the energy to the peasant, to the agricultural system, but at how much you are willing to sell that power? Because otherwise you cannot make an investment, because if you cannot pay back the investment, you cannot go to the bank and ask for the money, or to the bank, or to everybody, to any financial institution. Could be private, or could be a state-owned or international. Okay, so you have to know the revenues, and in your mind, you have to understand very well which is the real value of the power in your market. In our market, the power market in our countries, the power markets, we have different markets for power. It's a high regulated system. Okay, very, very high regulated system, because energy, like water, is I mean, is a basic need for the population. So we have a really highly regulated markets, and I cannot bargain the value of the energy, because we have kind of an exchange for buying and selling energy. But in less regulated market, or in market where you can develop local communities, then you have to ask yourself, what is the value of the power? Because if you're asking, I don't know, 100 US dollar per megawatt for supplying your PV energy to the peasants, to the agricultural system, they will not buy it because it's too expensive. So you have to to know what is the cost of the production of your power, and what is the gain, the yield that you can apply to your industrial cost. Those are concepts that we are going to see later. Okay. I mean, do you have any questions? Let's go and read the chat. The big issue let me down is that for the energy. Okay, you see, well, this is typical. Again, you have a lot of you have a lot of natural resources. In the case of Innocent, he's talking about sun, but he say the community is far away, about 100 kilometers. But apart from the fact that you don't also need a transmission, need stretching more, you can even imagine a PV power plant very next to the areas where the demand is reasonably high. Why do you have to place 100 kilometers transmission line? So you can think of about two power plants, one for the agricultural system, and the other one is for the demand, the local demand. PV photovoltaics is quite, I mean, elastic. You can install it easily in a lot of places. It's much easier than hydropower and even wind. So it's the easiest form of energy that can be produced, and also. I mean, yeah, it's very easy because it's very flexible. I have two of them, of course, Innocent. You don't need, again, we are talking about a decentralized form of energy. So you see that those concepts are coming now again in this real case, no? So we can imagine to have two power plants and not be one big, because if you imagine to have one big, then you have to create the line. But we don't want to spend a million of euros for installing 100 kilometers of lines. So we prefer to have local grids, local smart grids, maybe the same model that I have shown you before. Allora, this one. Okay, we want to have tens of this. This is very easy, very local, and it can work standalone without being connected to the grid, or could be connected to the grid, but it could work standalone. Do you have any questions?
Yes, there is another one from Derek.
Allora, Derwick, let me see what. Derwick, what do you think is the convenient and better window time to pay back that? What do you think is the convenient and better window of time to pay back the borrowed funds that and then project? Allora, so as I mentioned at the very beginning of our lesson, we are dealing with the long-term investments. Okay, again, infrastructures means long-term. Speculation means short-term. Okay, but we do not want speculate here. We want to create value. We want to create development. Okay, so we are speaking about long-term ideas, long-term projects. So I will show you in a business plan that if you have to undergo an initial big investment, and here are the costs. So per megawatt, 1 megawatt of PV costs from 700,000 euros up to 1.2 million euros. 1 megawatt. 1 megawatt, it's about 1.5 hectares of land. Okay, and it can produce, say, let's say 1.6, 1.7 million of kilowatt hours per year. So let's say that it's not a huge plant, it's kind of good plant. But, and this is, we call it, commercial and industrial CNI plant, because this is the dimension typical of a smart grid or a small grid. Okay, for supplying local communities. So say that you have to invest 1 million euros for local communities, and how much are you going to sell the power, and what are the costs, the operation and maintenance costs related to your power plant? This is something that we are going to see in a business plan. But I would say that if you ask for a loan, the length, the duration of the loan must be not less than 7, 8, 9 years. I would prefer 15 years. 15 years time to pay back the loan. In the same times, you have the revenues. With your revenues, you have to pay back the loan, you have to pay back the operation, maintenance, and there will be some money left for you. Okay, I would say it takes not less than 5, 6, 7 years. Okay, the payback period typically of a PV now this day with the actual costs, it's not less than 4 or 5 years. But if you go for a loan, I would suggest you to a duration more than 5 years, if you can do as long as you can. Chat. I think depends on the amount of money borrowed and the break-in of the infrastructure, of course. Do you advise Deus? Anyone starting to use rented or leased land? Yet we are talking about long-term investment. Do you advise anyone starting to use rented or leased land? Yet we are talking. Yes, you can use Deus. You can rent land, of course. It's a cost. So once you put in a columns, you put in columns your costs. You have the operation and maintenance cost. Then you will have to rent the rental cost of the land. Then you have the loan, the payback loan, interest and capital rates, and then maybe you have other costs, or I don't know, some other thing you have to pay for the goods, the material, raw materials, and so on. Okay. No. So this is I'm talking about electricity value. Oh, this is a concept which is very much related to renewable energies. As I mentioned you in advance, renewable energy are not programmable. So you have uh, to evaluate very well your investment. Why? Especially in wind and hydro, not in PV, because PV it's quite predictable. Let's say that between one very sunny year and one very rainy year, I would say the difference in PV production it's not more than 5 to 7%, 8%. Okay, so let's say that the yearly production of a photovoltaic plant, it's quite the same every year. It's quite constant. This is not for hydro and wind farms. So what does it mean? It means that the red line is the average production. So you see, we have calculated the 7 years of production. The average production is the red line. The actual production are the gray lines. So number 1, 2, 3, the production is above the average. Number 4, 5, 6, it's below the average, and again 7 is above. So if you don't pay attention to the concept of non-programmable source of energy, you can incur in a fatal error that during the year 4, 5, 6, you incur in a financial breakdown, because remember that during every year you have to pay back the loan, the operation maintenance cost, the personnel, and so on. The 5, 6, and number 4, 5, and 6, your revenues are below the average. So during those years, if you don't pay attention in the years that you have production above the average, in those years you will suffer because you won't have money for paying your costs, especially the loan. Okay? And so you can have a serious financial crisis. This is a typical concept of the renewables. Oh, this here now I'm showing you some, maybe some of you already know that, and for others, those are new concept. You have to evaluate the how much is your investment, how worth is your investment. So how do you analyze your investment? There are some methods, basically two of them: the discounted cash flow method and the levelized cost of energy. We are talking about energy now. So the discounted cash flow calculates the net present value of the plans based on future cash flows according for revenues and cost, and discounted using a predetermined rate. It provides the current value of the plant. So let's analyze this formula. For this probably is familiar for some of you, but for the one to whom this formula is not familiar, this is very easy. The VA it's the actual value of the plants. It means the value of the plants considering the cash flow of the years of the useful life. So the sum goes from 0 years to n years, where n is the useful life of the infrastructure. In this case, is the power plant. Let's say 20. The cash flows are the cash flow of the years E. So it's the sum of the cash flow of each year for 20 years. Okay. What we find, what is R? R is the interest rate. So you see, as I mentioned before at the beginning, the cost of the money is an essential parameters in order to evaluate your investment, because the higher is R, the lower is VA. So this is why, again, asking for the money is not simple, because you have to negotiate the best rate, and sometimes the rates are not negotiable because of geopolitical situation, for example, the cost of the international cost of money. So in order to what you want to have here, you want to have a VA very high, an actual value of your plant very high. In order to have an actual value of your plant high, you have to have a high value of C per multiplied F, cash flows, and you have to have a low value of R, interest rate. If you want to have a low value of cash flows, you can have it by two factors: a lot of production and a good price of energy. Okay. By the way, in an example that I'm going to show you, we will use this one. We use the discounted cash flow system, because it's the same system used by the banks. So I suggest you to use this one, this this method. The second method is the levelized cost of energy. This formula, this metric, calculates the unit cost of electricity over the plant's lifetime, representing the break-even price. Okay. With LCOE decreasing as production increases and costs rise. Okay. LCOE helps assess the competitiveness of renewable projects and compare different technologies. Okay, what is LCOE? Let's go back here. This is the value in terms of euros, of money, of currency, of your plant as it is today, projected in 20 years. The lifetime of the power plants. This value here is expressed in euro or dollar per megawatt hour. So it's the costs of the energy. Okay. How do you calculate this? This is the sum of the cost over the lifetime and sum of the electrical energy produced over the lifetime. Okay. So it's easy to understand that what you want to have here, you want to have LCOE low, because this means that the cost of your production, let's call it the industrial cost of production of energy, is low. So you can sell the energy at a higher price. So you want to have your plant with a low LCOE. How can you do that? You see the formula is easy. It's the sum from the year number 1 to the year number n, let's say 20 years span. It's the first sum is the investment expenditure, operation and maintenance, and fuel. In renewable, of course, the fuel is zero. So you only will have the investment and operation and maintenance. Okay. And down here you see again the rate, interest rate R. Again, it compares. It's here again, and it affects the value of the LCOE again. The higher is R, the higher in this case is LCOE. Okay, so you wanna have low costs of maintenance and low investment and expenditure, and you want to have a very high amount of energy produced, because at the end of the day what you need is else a low value of LCOE. Okay, let's see a chart. This is a chart from Lazar 2024. Every year, Lazar is an international financial bank. So it's a this is a financial institution, international financial institution. Every year they release a report on the worldwide energy markets, and they release a value of levelized cost of energy comparison, you see LCOEs, and it's quite interesting because those are worldwide values. And there is, I mean, interesting enough, in this chart, there is no hydro. There isn't the hydro. It's only solar PV, different dimensions with storage, geothermal, wind plus storage, and wind offshore. And then conventional energy, gas, US nuclear, coal, and gas combined cycle. But this is interesting anyway. I'm sorry that there isn't the hydro, but you can see the rooftop residential LCOE ranges from 122 to 284 dollar. Okay. Then solar CNI. CNI means commercial and industrial, which are the power plants, let's say from 1 to 5 megawatts, let's say something like that, 1 to 10 megawatts. You see that the value of LCOE are lower, so they are decreasing at the increase of the dimension of the PV plant decreases the LCOE. Okay, so small power plant, rooftops, very high LCOE. Medium size PV, the LCOE decreases ranges from 54 up to 191. Very big power plants, PV power plants, goes from 29 to 92. If you add storage here, you see that the LCOE raises up again because the batteries are expensive. The LCOE goes from 60 to 2000 to 210. What I want to show you here, let's go here, gas combined cycle. It goes from 45 to 108. So you see that it's competitive with photovoltaic. But here in a photovoltaic, you have a production of 1,600, 1,800 hours per year. Here you have 8,860 hours per year. So with the same LCOE, you have 4 times the quantity of energy produced by PV plants. Okay, I hope this is clear. Being far away from you doesn't help to understand those concepts. Being with you, it would be easier for me to explain this. Let's see in a chat. Thank you, Bonazzi. I'm not Bonazzi. My name is Flavio. Flavio. My first name is Flavio. My second name is Andreoli, and my third name is Bonazzi. So please call me Flavio. Okay. Maybe you have. I mean, I have introduced you a lot of arguments, a lot of them, which are not easy. So I'm not surprised if you have some criticalities in order to absorb those concepts. So please don't hesitate to stop me and interact with me.
Yes, Flavio, we have 10 minutes more. So if you can so finish on time, just to advise you.
Yeah, I mean, as you prefer. I
If you want, so if you have, this is what, if you want to, we can also close earlier, or just to let you know that 10 minutes at 4.
Okay, let's. I want to show you a real case. Okay, maybe I show you a video. Now I am going to the phase of scouting the project. So once you have all these theoretical concept in your mind, let's apply them to real project. So scouting the project. Let's go in the land search for the project, as Innocent did. Innocent went in his village, in his country, and scouted the project, thinking that using solar power could help the agriculture. So he scouted that project as I did. And I want to show you a real case example of one power plant, Villa Sant'Antonio Uno. It's a power plant on an irrigation system. I hope it works. Katyusha, please help me. YouTube. Okay.
Yes,
You see it?
yes.
Okay. So I already show you some picture of it. Let's stop it. Where is the river? You see the mountains in the back? White mountains with snow. The river is coming from that mountains. It flows right in the middle of the valley and arrives at the sea about 30 kilometers down the valley. Okay, from there is the intake, the intake of the irrigation system. The irrigation system is made up by this canal. Is about here, about let's say 5 kilometers up, uphill with respect of the powerhouse. So the intake is about here. So from the intake from the big river, the water flows into this canal, and this canal goes, I mean, flows, run horizontally on the land, but of course it needs to decrease his elevation on the sea level. How and how it occurs? I mean, you see that the irrigation canal at a certain point here is a stepped canal. So it weighs head. From here to here, there is a head about 12 meters. Let's now, it will be much easier to understand. This is the power plant. So you see the stepped canal. You see, this is the irrigation canal flowing downstream. Okay. Okay. So this is the canal. The original route of the canal was this one with this stepped canal used in order to lose head. But what we thought, why shall we lose the opportunity of using this excess of power? So this is the intake of our penstock, of our pressurized pipe that goes underneath here underground to the power plants, which is the white house. Okay, that releases, discharges the water again here on the down the river, on the downhill canal. So we have used the irrigation canal as an abduction canal. You see, this is the intake of the power plant, and this is the stepped canal, this one. The penstock runs underground here. This is the power plant where the turbine is located. Then the discharge goes directly on the canal. Ok? Questo come si ferma? Ok. Now, mo come si fa a chiudere? Mm, 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 mm.
You can close directly the page of YouTube if you prefer. Up,
Sì, ma non c'ho sto cazzo.
up the,
Ok.
yeah,
Yes, but now I have lost.
what?
I have lost the presentation.
And down, I suppose you can close internet. So, sorry, speaking in Italian.
Okay. 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 So I've shown you this project. The cost, the capacity is 520 kilowatt. The average capacity is 350. Annual production is 2.5 million kilowatt hours, 2.5 gigawatt hours per year. The cost in 2006 it costed 1.2 million with an annual revenue approximately of 200,000 euros per year. The plant initially benefited from an incentivized tariff, but now sells energy on the open market because the Italian government stated that if you are installing new renewable energies power plants, you have an incentivized energy prices. So we enjoyed the incentives. Um, of course, I would I have put in my material. I have posted in my material the business plan of this power plant, so we can analyze it thoroughly later. From now I want to show you some other ideas of of local development. This is south of Italy. You see, south of Italy in a region called Calabria, the extreme south of Italy. This is Sicily, and here we have made a kind of important development of different power plants. You see, five of them, and we have scouted the territory for many years with the ideas of a local development using, using the idea of the co-use of irrigation systems. In this case, we have used we have worked on two irrigation schemes. One in the north, you see here there is this artificial lake. There is a huge dam. Do you remember the dam that I showed you at the very beginning? This is the dam. This is the dam, and these artificial lakes. Supply the water for irrigation to all this region. Okay, all the way down to the Ionic Sea here, where the red dot is. Okay, and this is called the Esaro system. Heading south, there is the Mucone system, on which we have already installed the first power plant, and this year we will start the work of the third power plant, the Mucone 3. The Mucone 2 is coming. We have already installed Esero 1 and Esero 3. This is those plants were the fruit of scouting of years. And I want to show you some stuff. Okay, I want to show you the video. Okay, so you remember the big dam I've shown you before? Okay, this is the big dam. It's 1 kilometer dam basically. And from here starts the irrigation system. So this is the pipe used for supplying the water. This is the main pipe for supplying the water to the irrigation system. Okay, this is our power plant SR1. Okay, You see how big this system is, and it was built 50 years ago. So we only use it for the purpose of, you see, this is 1 kilometers for the purpose of finding out excess of energy. And okay, here is clear. This is the main pipe of the irrigation system. It's 2 meters and 2,200 millimeters is the diameter. This is our power plant Esaro first, which uses the vital discharge from the dam. So from the dam, as I mentioned before, must be released a minimal quantity of water in order to let the river survive. We used this water coming from the dam in an underground pipe. The water entered into the turbine and is discharged here and released to the river at this level. Okay. The water, which is not going for vital use of the river, flows in those system of pipes, and it flows down the river for about 20 kilometers. Okay, and on this pipe we have installed the Esaro third power plant, 12 kilometers from here. In that case, we utilize an excess of energy on the pipes. I show you the hydraulic scheme. See, this is big. Ok, ok, io non riesco a... Ok, so it's 5 o'clock and chat. A lot of people. Thank you, very interesting. It's hard. Thank you. It's very good. You could share. Katyusha, we really appreciate the presentation. Perfect. Thanks. Very interesting presentation. So, maybe it would be to help us know the environment that you have while setting up some of this project. Okay, please keep your question for the next lesson, so we can keep on going. And Katyusha, do you think we can stop it?
Yes, absolutely. We have many messages in which the people know enjoy and appreciated your lesson. Thank you very much, Flavio. Flavio will be again with us Tuesday. And tomorrow we will have again Benedetta Giuliano with a lesson on building to last sustainable models and entrepreneurial ambitions. So you are again invited to join. The link is the same of today and yesterday. As today and as yesterday, tomorrow morning I will send you a reminder. So it's all a proposal. Thank you very much, Flavio, for your really interesting presentation. I know that the people usually are looking for a practical approach and really best practices and experience to share with them. So thank you very much, and all of you see you tomorrow at the same time and using the same link. Thank you, Flavio.
And I see you on Thursday.
Yeah.
Thank you very much.